Hello viewers, I hope you are doing alright. Today we are going to learn about the undercarriages of an aircraft and this is part one of two parts, and our today's objective will be to learn about the functions of the undercarriages and the requirement for the best undercarriages. We will also learn about the layout and the shock absorber. There are two main functions of undercarriages. Number one is to provide the movement on the ground, and number two is to absorb the shocks during landing and to provide a smooth landing and a smooth taxiing while on the ground. Now, if we discuss about the requirements of the good undercarriages, it must be able to withstand the high load of the aircraft, and it must maintain the altitude on the ground, and it should be undercarriage itself should be light and small. We can say like nearly 4 to 5% of maximum takeoff weight, and they should be retractable so that the drag can be minimized, and the material used and the technique used should be reliable because the failure could be catastrophic. There are three main types of layouts. Number one is a bicycle layout, number two is a tricycle, and number three is a tailplane. First of all, we will discuss about the bicycle layout. In this type of layout, out triggers are compulsory, and the landing must be controlled carefully. And the main wheel units are placed forward and afterwards the center of gravity, so that there is more space available in the fuselage. And the very common example of this is Lockheed U-2 spy plane and the Harrier jet, the picture of which is shown here. Next is the tricycle layout. In this layout, there is one wheel unit near the nose section and two main wheel unit under the wings. This type of layout gives low drag during the ground run, and nose down pitch reduces the lift during the landing, which prevents bouncing back of the aircraft. Now, in this type of layout, pilot's view is improved compared to the other types because the fuselage is nearly horizontal in this layout, and it also prevents the overturning during the braking. Tailwheel layout is opposite to the tricycle layout. It is light and small compared to the other ones, and there is no need of tail bumper in this type of layout. And retraction methods are also simplified and not too complex. And as it is opposite to the tricycle layout, so the fuselage is not horizontal in this type of layout, in this type of aircraft when it is on the ground. If we talk about the wheel layout itself, so it could be a single wheel layout as found on the many small aircrafts, or a dual wheel layout like found on the commercial aircrafts in the nose unit, or it could be a tandem wheel layout, one wheel after the other, or a dual tandem wheel layout, also called as a bogie. This is a type of layout in which the tires are in the set of four, and it could be also a tri-tandem wheel layout like found on Boeing 777 six-wheel bogie. Shock absorbers are found on an aircraft to absorb the shock during landing. Now, in light aircraft, this could be a steel spring with a rubber mounting, but in larger aircrafts, we cannot use the rubber stuff and steel spring. So we use the compression struts and dampers to absorb the shock. There are two types of shock absorbers mostly used. Number one is the oleopneumatic, and number two is the light spring shock absorber. First of all, we will discuss about the oleopneumatic shock absorber. It uses oil and gas, and the gas is mostly nitrogen gas, and it has two cylinders. First one is the outer cylinder, and the other one is the inner cylinder. In inner cylinder, hydraulic fluid is found, mostly the oil, and the outer cylinder has air in it. So during landing, the inner cylinder moves upward and oil also moves upward, hence compresses the gas at the top of the cylinder. So it acts as a spring in large aircrafts. Now the motion of the oil in both cylinders is controlled by the valves. Next one is a liquid spring shock absorber, and it works in the same way as oleopneumatic shock absorber work. The only difference is that no gas is used in this type of shock absorber, only the oil is used as a compressing or as a damping medium. And the picture is given here in the for the liquid spring shock absorber and for the oleopneumatic shock absorber as well. And as I have told earlier that liquid spring uses oil and it does not uses gas, so more pressure is needed to compress oil. That's why liquid springs have high operating pressure and small volume changes. And the energy is absorbed by the oil itself and it gets heated. So this is how the shock absorber work in most commercial aircrafts. That is it for today's video. I will see you in next part of the undercarriages.